Hi everybody, Keith Tanner here from Flyin Miata, and today we're going to talk about something that's actually been creating quite a bit of interest. We've had a lot of questions about this one, which is great. Today we're going to talk about individual throttle bodies, ITBs or individual runner throttle bodies, IRTBs, basically one throttle butterfly or one throttle per cylinder. Here's an example of what I'm talking about. This is a set of ITBs. This is designed to fit a Miata 1.8 liter engine. But this is the general concept of what we're looking at. A normal intake, don't mind the dust in this one, this is the top half of an MB intake. The throttle body goes here, air comes in, gets separated into the four cylinders here, and then runs around underneath and into the head. And what the individual throttle bodies do is they effectively shortcut that and get a very small run between the throttle and the head. And this means less throttled volume, quicker response, and also a very, very fun noise. So I'm going to back up a little bit and just say I've been playing with throttle bodies on Miatas for about 15 years now on various cars. I've been doing various dyno experiments with them. I don't have any on a car on a Miata today, but I have been playing with them, and there's a reason I've been hanging on to this set, because you never know. I have found that some things they do work for, some things they don't work for, but they've always been popular, and they've always been one of those things that gets a lot of interest and has a lot of mystery around them. But is this magical thing that does all sorts of stuff? And so hopefully today we'll be able to discuss just how magical they can be or are not, what they're like to live with, and what various things can do to affect their power output. Now, if you are watching this live on Facebook, please do put questions in the comments. I'll do my best to answer them. I have a list of questions that people put in ahead of time, which is fantastic. If you're watching this on YouTube or on Facebook later, put them in the comments. We will do our best to answer them in the comments. I will tell you ahead of time, this is more of a general overview than a series of recipes. This is not a cookbook. This is not saying that what you need is a 42 millimeter throttle body and a trumpet that is 105 millimeters long in order to fit a Miata with a webcam 505 cam and 11.5 to 1 compression. That is not, I know there's one guy out there who wants that particular answer, but unfortunately that's not what we're going to be talking about. I'm going to be talking about what the various aspects of them do, how they work, what's difficult about them, that sort of thing. So I apologize for that one guy who wants that one answer. I don't have it for you today. So, yeah, the entire name of the game is throttle response. You've got this throttled volume between the actual butterfly that's controlling the air going into the engine and the valves. The bigger that throttled volume, the more lag there is from the time the throttle moves and the time that air arrives at the valves. One of the things you can actually do with an electrically operated throttle body, as on newer Miatas, is that way the ECU knows the slug of air is coming, so it can actually anticipate, which is actually pretty cool. A lot of people rag on electrically controlled throttles because they think it has a problem with throttle response, but it can actually be the exact opposite. But another way to do it is simply make that throttle volume smaller, and that's effectively what throttle bodies, individual throttle bodies do. As you can see, this is the limit. This is the amount of throttle volume on this particular setup, which is a TWM setup, I think. Yes. You know, the throttle is right here, and there is the port right there. And then it's just a short run into the valves. And there are some versions that put them even closer, so you can have even less throttle volume. So, yeah, there's a chance there for basically the engine to be able to react very, very quickly to any changes in throttle, and that's the appeal of throttle bodies, is that razor sharp throttle response that you get. Travis, do you have a question? Okay. I apologize. Our microphone system, if you're watching this on Facebook Live, our microphone system, there's been a Facebook Live update that has made basically shut down the microphone system. So if you do have trouble hearing me, Travis will hopefully signal to me and tell me to talk louder. I apologize for that. Those of you who are watching this after the fact, we're going to patch in some pre-recorded video so you can hear it properly. So I apologize to those who are watching live, but you guys get to ask questions that are being answered. So there you go. So those are the upsides to throttle bodies. Very, very low individual throttle bodies. Very, very low restriction. You can see there's just a straight shot. I am a valve, and I can see right through this thing, and then I can't. It's all about the response, and the noise is fantastic because there's nothing filtering it. But the downsides are It sounds fantastic, but it's also loud, like you would not believe, because you're getting that noise, the intake noise, basically unfiltered, literally in some cases. A stock assembly, it runs through the intake manifold, through the throttle, and then through about 4 feet of piping with resonance chambers, and then an air box, and everything's designed to make as little noise as possible. On this thing, as you can see, we get the noise right out of the engine pretty much immediately. So they are noisy, and it's not always fun noisy. If you combine them with a high compression engine, you will get a hammering noise like you would not believe when you're running around. It does certainly affect the civility of the car. It is going to be a noisy car because of that. Just be aware. Noise can be cool, not always cool. I have actually failed sound levels at Laguna Seca because of intake noise on a car running this actual setup. The amount of intake noise coming out of that car was enough to trip the sound meter at Laguna Seca. Not on a 105 decibel day, I'll tell you that. So that's one of the downsides, is they are noisy. It's a plus for some, it's a minus for others, but just be aware, especially high compression, very, very noisy. They're also a little more difficult to tune. And some of that is to do the very small variations in vacuum available, and I'll get into this a little bit more in a bit. But basically they run in a smaller range of vacuum. It's a little bit, because everything's happening so fast, it's hard to, everything that is reacting to it has to react much more quickly. It's harder to sort of get on top of the system. So it's easier to get starvation, tip in, lean tip in, that sort of thing. It can be a little harder to hang on to stuff. You have a question, Travis?
Any plans for us to make a kit for the ND?
Are there any plans for us to make a kit for the ND? I guess we should get this one out of the way right away, huh? One of the problems with them is the difficulty in getting emissions, getting them through emissions. And because of that, it is highly unlikely that Flyin Miata will be developing a kit for the ND. I admit the ND, especially the ND2 engine, could be a lot of fun with individual throttle bodies, but we are going to have to leave that that fun to someone else. Very few of the parts that I'm going to talk about today are sold by Flyin Miata. So I apologize for that. That is the world that we live in. We have to stay emissions legal as much as possible to avoid getting in trouble with the EPA, and also because we live in a beautiful place with clean air, and we like beautiful places with clean air. So unfortunately, we do not have any plans to develop an individual throttle setup for the ND at this time. So there's one of the problems with them, is emissions. There are no emissions legal options out there right now. Depending on where you live, depending on the year of your car, that may be a larger or smaller problem. They are available for the NA, for the NB, and for the NC. I know the BBR has NC kits available for them over in the UK. I believe they have to deactivate some of the emissions control equipment to do it, so they're not emissions legal, but there are kits out there for them. Another thing they have trouble with is they usually have trouble, and this comes into how they are tuned, have trouble dealing with altitude variations. And that is something that we here in Colorado are a little more aware of than some other folks who live in an area of slightly more consistent altitude, shall we say. We can easily run out here and run up a fun road that will gain us 4,000 feet in elevation, 5,000 feet in elevation quite easily. And so we become quite aware of altitude variations and the difficulty in tuning around that. And also it can be difficult to get the idle and the cold start working well, because as you can see, there is no idle speed control valve on this thing. That makes it difficult. You can't even put a choke on this at the moment. So how do you deal with cold start? So that is another challenge with ITBs. So let's talk about how to actually make it work. Any more questions at the moment, Travis? He's making a face. No topic. No questions on topic. All right. Okay, so how to make them work. What do you need to run individual throttle bodies on your car? Well, I mean, other than the obvious, you need something like this. This is a one-piece unit from TWM that is relatively unusual. You don't see the monolithic ones like this. I think, starts with P. I'm drawing a blank. I want to say PV, but those guys make guitars. I believe there is a Gen V, sort of like PV, right? Gen V, I think, makes one-piece units for the NA and NB as well. But most of what you see is a short adapter that has a standard sort of Weber flange on it, and then you can bolt on throttle bodies that happen to have Weber flanges. I think some out of the Injectors are often used. There's some Toyota ones that are often used because they have sort of accidentally come up with a standardized flange. So all you really need is that adapter. You can get those from Pierce manifolds. You can get those adapters, at least for some of the cars. If you are looking for those sort of adapters and you've got an NC, remember that the NC engine is also a Duratec, and you'll probably find a lot more parts for a Duratec than an MZR. Anyhow, this one is monolithic, but effectively they work the same way. The only difference is just, there's one more place for them to leak if they're a two-piece unit. So you need a set of these. You need a way to measure the airflow, or the amount of air going into the engine. That's where it can get tricky. Stock Miatas use either a airflow sensor, an airflow meter, or they use a MAF, a mass airflow sensor. The problem is that unless you've got all the air going through that, you can't measure it. And I'll get to that in a moment. So you can use manifold pressure, which is minimal, but you can measure the pressure in each of these individual manifolds. Or you can go off throttle position. The problem with going off throttle position only is it assumes a certain ambient pressure. And I've seen, the guys coming out of the UK, we had a bunch of guys with Lotus 7s, Caterham 7s, come over and do a run across the US. And when they got to Colorado, their cars were falling all over their own faces because they were all tuned with the expectation that they would always be at sea level because they live in the UK and you're never that far from sea level in the UK. So they were running off pure TPS, and you can't do that when your ambient temperature changes. So what people often do, and I'm a little weak on this area because I'm not a tuning specialist for ECUs, is they run a mixed map and TPS, I believe. That's what it's on. I think it's called Alpha N. I'm sure someone else will jump in the comments and give a full dissertation on that. I am not the guy to give that dissertation, but you do have to take that into account. Even at sea level, even at a consistent altitude, you do have changes in barometric pressure, which will affect what your TPS, what your actual pressure is with the TPS setting. You will likely need to run an aftermarket ECU because the stock ECU is expecting a map signal or an AFM signal if it's an early car, and it will probably not be very happy with the fact it doesn't have one. Well, it won't work. So there is a way to make a stock ECU run, and we'll get to that in a moment, but it can be challenging. So the difficulties in tuning, and again, I always jump in with the questions and comments if anything helps. And I am going off a script here, which is, if you watch many of these videos, that's unusual because you guys have asked so many questions. The difficulty in tuning comes from the fact these are such small manifolds. Effectively, it's got 4 individual intake manifolds, and they run a very small range. They don't pull much vacuum, honestly. And when I was running one car on a Link ECU, the Link ECU, well, like many ECUs, like a Mega Squirts and just about everything, it had tables to run the fuel and the timing. And the rows of the table were based on manifold pressure. It went from, there were 6 of them in that car. And the one with the highest manifold pressure obviously was full throttle. One with the lowest manifold pressure was closed throttle deceleration. Idle was, 1 or 2 up from there. It only used 2 of the 6 rows because full throttle pressure was so close to idle pressure, especially with the cams I had in that car, that you basically had the choice of, do you want the full throttle map or do you want the not full throttle map? It made it very difficult to tune. Obviously, an ECU with a little more granularity in how it could be set up, you could work your way around that, but it does still present a problem. You've got a very narrow range of operation with these things, honestly, which makes it difficult to work off map directly, or map. So how can you make them work better? Well, one thing you can do is you need a little plenum. You need something to basically act as a reservoir for vacuums so that you can put an idle control valve on there and also give you a more consistent vacuum signal. So when I ran these, and actually I'll show you a picture. When I ran these on one of my cars, the Targa Miata, which you have seen recently, I had 4 lines running to a vacuum canister, effectively, a little plenum over in the corner, and there was an idle speed control valve attached to that. I think originally it came, well, it's not a very good picture, it's an old picture, but you can see there's an idle speed control valve on there, off a stock Miata, and it's attached to this block that has lines running to each of these points on the runners. And the purpose of that was to allow the ECU the ability to control the idle when it's cold. It could allow a little more air in. Keeps it from idle drooping. So it did give a little more control for the ECU, and it also gave me a more stable signal for the map signal. So that improved the drivability considerably over the one where I just kind of took the runner off one to see how it would work. Another thing that helps a lot, of course, is to have an idle switch, which this is a difficult thing to do on this particular car. I can't remember how. I think I had a TPS on here, that's what it is. I had a throttle position sensor on this little on this little trigger right there, it had an idle switch so that the car did know when it was at idle. There are a lot of people who just kind of wave their hands and go around this and say, oh, whatever, you know, I'll keep it running with my foot when it's cold, you know, use the manual choke method of just keeping the throttle open a little bit. I've done that with a track car. It's a bit of a pain in the butt. You can do it, you can get away with it. I'm trying to show a good way to do this as opposed to what you can put up with. So ideally, you want that little reservoir. I think there are some available on the market. If not, some time with a drill press and a block of aluminum would probably do the trick. 3D printing if you're wired that way, and you could make a nice little vacuum reservoir that you can use to control the idle. We had a lot of questions about where the best place for an intake air temperature sensor would be, because of course that's another factor that the ECU uses to make sure that it's going to run properly. It gives it an idea of the density of the air. And the nice thing about naturally aspirated cars is that the temperature of the intake's charge doesn't really change. You know, with a turbocharger or supercharger, it has to go through that compressor, that blower, that basically heats the air up. And so you've got to make sure that you're measuring the temperature where it goes in the engine and not before it goes into the turbocharger, for example, because it could be radically different. Luckily, in this case, it just has to be somewhere near where the air is coming from. I have in the past, I think it's time for another picture here, Travis. There we go. This is what I did on one car. I'm showing different lengths runners on this, but what I did with one car, that is the air temperature sensor. I simply stuck it to the backing plate for the air filter because it's going to show, you know, it might be off by a degree or two, but that was good enough to work. And that's all you really need. There's no one ideal perfect location for the air intake temperature sensor because honestly, it doesn't change that much. You know, don't put it over the header, put it somewhere where the air is coming from for the intake, but that's all you really need. Okay. Let's talk about air filters. Yeah, let's talk about air filters. Now, usually when you see these things, yeah, I'll do it. I'm changing things up. Look at this. I'm going freestyle. Usually when you see pictures of throttle bodies on cars, individual throttle bodies, you see them with just open intake horns like this because it looks sexy. Everyone loves seeing these things. Yeah, look at that. Problem is, that's like feeding your engine sandpaper. You'll destroy your rings. You're going to wear everything out internally. Make some, you know, we have air filters on our cars for a reason. You don't want to run without filters. That's just plain stupid, seriously. So how do you filter them? What you see on a lot of cars, you'll sometimes see, is you'll see like a little mesh dome over there, which looks cool, looks very old school, completely ineffective. It won't filter anything smaller than a horsefly, but it also backs that up with high, with power loss because it's fairly surprisingly restrictive. So that is possibly worse than running no filters at all because you get the power loss on top of the fact that you're eating in anything, you know, all the dust, anything short of like a rock is going to get in there anyway. So that's a bad choice. You often see some with socks. That one that I had a picture of a moment ago, you saw there were socks on the, well, I'll put the back up for you because maybe you weren't looking. This one had individual socks on each, over here. Yeah, there we go. Look at the giant finger coming in. You have individual socks on each of the runners. That one did okay, but it did exhibit a little bit of power loss when measured on the dyno. Now I'm going to show you one other one, and that is this thing, an enormous Itg filter. There are two different types. There was this cone one I used, and then there was this big guy here. Absolutely no power loss at all. That had made no difference whatsoever on the dyno because if you just look at the surface area on this critter, it's enormous. Problem is, it's a little hard to package on a car that keeps its intake inside the hood, which this car did not. So packaging problem there, but that is ideal. You should run a filter. If you can run a filter that is enormous and has lots and lots of surface area, fantastic. You can do that. There is another option, and that is to run a plenum. Now what that is, this thing is stuck right over top of this backing plate, and it's basically just a big box. The air comes in the front here. It looks kind of like a normal intake manifold, except the throttles are, of course, past the intake manifold. So you've got this big intake plenum, and then I had a hose running off that to a filter that was actually outside the engine bay, so I had lots of nice cold air, and it was a filter size for 350 horsepower car, so that worked quite nicely as well, and that's probably the best way to do it. It's not the sexiest way to do it by far, but it is a good way to go. If you are looking to control sound, this is the Laguna Seca solution here. And you're also looking to basically make sure that you keep your engine healthy and you have nice cold air coming into it. And the nice advantage on that is that all of the air coming into the engine is coming through a single pipe. So now you can put a MAF on. So in theory, that could work with a stock ECU. Haven't tried it, but that would be the way to do it. Run an intake plenum on there, filter the air, or not filter, meter the air going into that plenum, because it's all going to go in the engine anyway, and then that'll give you a pretty good idea. It'd be interesting to try. If you have tried it, please let me know, because I would love to know if you can make a stock ECU work on on ITBs on a Miata, and that's what you would have to do to get it through missions. So in theory, that would be the possibility. So there we go. Go back to my notes. Travis, do we have any questions?
Not that I've seen yet.
Not that you've seen, okay. This, by the way, is the air filter that was originally built for that plenum. This was just supposed to stick in the end of it. It was a little small. It does have a decent amount of surface area, but I replaced that with, like I said, one out of one of our turbo kits, so it was considerably larger. So, one of the coolest things you can do with these, and one of the things you can see, obviously, is you can change out the horns, the air horns, and effectively change the runner length. And this is where things get really interesting to play with, because you can change the shape of the curve with these things. In theory, and I'll show you some dynos in a bit, the longer the horn, excuse me, you'll get more low-end torque, more low-end power, really, it's all the same thing, at the expense of the top end. This one is the low resistance one, but it doesn't have the torque to it. So this is the super high RPM options running these short ones. And as you can see, I have quite a range. These are all ones that I've used for various tests over the years. There's not even all of them. Packaging in the different lengths can actually have quite a good effect. And I have some dyno charts to show you. Here's what they actually do. Let's start with this one. There we go. So this is a test on a little 1.6 of two different runner lengths. I might have showed you that. Can you see that okay, Travis? I may put links to these various charts and things in the comments of the video later so you can see them. But as you can see, the short runner is the blue one. So there was a loss in torque in this area, which is about 45 or 5,000 RPM, but a gain in power above 55. Do I have that right? Actually, it kind of looks like the red one was a winner overall, doesn't it, in this case? The long runner was actually a better choice overall in this particular car. So I ran with the long runners, actually, in this car. So this is a bad choice. Let me get the other one. I've forgotten that I did that. It's been a long time. Okay, don't mind some of the weird stuff going on here. This is another short versus long. And again, the long one actually performed better overall, contrary to the way it's supposed to work. And the general takeaway from this is basically run the longest one you can. And yes, I know there's some weird curves in this. Take this as a before and after. Don't take this as like the ultimate dyno chart, but you can see the effect of those short and long runners. And that is actually the setup I have on the bench right now. That is this one versus this one. Didn't make a big difference in peak power. It made a difference in the mid-range, enough that I wanted to package as long a runner as I could. And packaging is where you often comes into trouble. Again, on that little Lotus 7 replica, I was able to stick this thing out the side of the hood, no problem. I could run the longest runners I could without like hanging it up on street signs. Underneath the hood of a Miata, obviously you get into the point where there's just no room to put filters on, or there's an ABS unit over here, or a shock tower, all sorts of awkward things that are considered required. So you may basically, on a Miata, you want to run the longest runner you can package, and that packaging is probably going to be the limiting factor. I have one more dyno chart actually to show you here. And this is what effect, I should have shown you this right at the beginning, what effect do throttle bodies have on an engine? How much power can you make? This is a straight before after. No changes were made to this car between dyno runs other than the fact that I bolted on a set of throttle bodies. And the blue one is the throttle bodies. The red one is a modified 1999 intake manifold I've been doing some other experiments on, so it wasn't quite stock. But it was making similar power to what the stock manifold, but you can see what the effect is of those throttle bodies of that very low resistance up in the 6,000 RPM range. Even down low, it did better almost everywhere. So it was a clear win on this particular car. Made a racket like you would not believe, because it was a very high compression engine. But yeah, it was very effective on this particular car. And I found the same thing on my smaller, my 1.6. I don't have a before-after dyno chart, but it picked up close to 10 horsepower at peak. It really, really liked those throttle bodies. Okay. Yeah. So I'm actually going to show you. Oh, we have two questions. Travis.
Somebody was just requesting that you please don't forget to put the links to the.
Yeah, no, I will put those links to those dyno charts in there. Again, take them as before, after dyno charts. Don't take them as this is the ultimate Miata engine. This is more along the lines of halfway through building these particular engines. This is what I tried, and here's what happened.
And then the next question was, how would you differentiate the different ITB kits?
Okay, the question is, how would I differentiate the different ITB kits? I am not familiar enough with all the kits on the market today. I'd love to say that I know everything. I know there's some stuff out of the UK. Dan ST, I'm assuming that's how you say it. He's got a number of kits that are proving very popular in the Facebook ITBs group. I'm more familiar. I've tried a one-off kit that was made by, I think, TWM. I've tried this particular TWM kit. I have not tried everything that's out there. So I've never had my hand on a set of Gen Vs. They look beautiful. So I really don't have any comparison, unfortunately, between the different kits that are out there. I would recommend you look at, how easy is it to hook up a throttle cable? For example, this one, it's quite clear what happens. The little bracket goes here and the throttle cable runs around. That pulls on this. It's got a nice strong return spring. The cobbled together setup I had in my 1.6 did not have as good a return spring. It had a much jankier setup for the, I'm sorry, Xander, who owns that car now. It is jankier than this. It had a little more slop in it. It was a little more difficult to deal with. So I would take a good look at what does the mechanism look like that opens the throttles, how easy it is to adjust. And there is an important amount of information in terms of sizing as well. That comes into it. I'm not, the larger throttle bodies, I think it has the same effect as the length of the runners. I've not done any experimentation, but in theory, the larger throttles should give you, and I think this is the way it's supposed to work, should give you more peak power because they have less resistance, but they may cost you a little bit of torque. I have not tested that. I think that's the theory. They're certainly going to be harder to control at small throttle openings because the bigger the bore gets, the bigger the difference between closed and very slightly open. So that's me talking about ideas on that one. But what I'm going to do now is I'm going to show you a BMW M5 because that is obviously completely on point, but really there's a good reason for that. The M5 comes from the factory with 8 individual throttle bodies, which is very cool. And it's one of the reasons why this is a fantastic engine. Beautiful, beautiful engine. And as you can see, it's got a big plenum. The throttles are in here. This is the intake plenum. And it has 2 MAP sensors, which are problematic on this particular car, but whatever, that's how it's set up. It has 2 MAP sensors, so all the air coming into the engine comes through these twin air filters to these MAP sensors and into this plenum. Now, if we open this up, wow, this is a very difficult car to service. Check that out. Talk about long throttle runners. This is how BMW decided to package 8 relatively long runners inside a remarkably compact area. And you can drive the car like this. It sounds ridiculous, but of course it's unfiltered, so it's a little hard on the car, but man, does it sound cool when you rev it like this. And here you can actually see, well, I think it's a little bit greasy in here. I did loosen all this up beforehand, by the way. This stuff is usually plugged together. There's the actual throttle. And these are electrically controlled, actually, so the car has final control over what those throttles are doing. It uses it for traction control, and this car has the best cruise control you've ever seen. But you can see there's the length of the runner they're trying to run on that post or before the throttle to try to get some low end torque out of this puppy. This is a 400 horsepower engine. It does okay, and it revs like crazy. It's a beautiful, beautiful engine. But I thought it was really interesting to see this is a production application of independent throttle bodies, and that's how they did it. Is they did it with this big plenum. And this also means that you can supercharge. You can put forced induction on these cars because you ram some boost in there, and all of a sudden your individual throttles are living in a high pressure environment. And that case, that covering, we think it's aluminum, it's got a weird feel to it, is strong enough it can actually deal with that. So for those who are asking, how do I run forced induction with individual throttle bodies, that's what you have to do. You need a plenum, and you pressurize the plenum and let them breathe the compressed air, as the sorry, the high pressure air, as opposed to trying to do it afterwards, obviously, which would be difficult. You would also need a pretty good bypass valve to make sure you depressurize this plenum when you close the throttles. And then all of a sudden you've got all of that pressure somewhere. You want to have a pretty good bypass valve in there to make sure you don't blow the top off. So there you go. That's why we have this particular car here, because it is an excellent example of how to do it right. So do we have any questions right now, Travis? Other than thank you for finally explaining why there was a BMW in the background this entire time. Okay, I'm going to start. Some of the other factors that come in and are often confused with individual throttle bodies is things like fuel injector size, cam choices, a lot of stuff. You know, do you have to have specific cams for throttle bodies? Do you have to have specific fuel injector sizes for throttle bodies? And I think the reason they often get mixed up is because if you're trying to make maximum naturally aspirated power or get maximum response out of a naturally aspirated engine, then you're already doing things like high compression camshafts. So are you doing the cams because of the throttle bodies? Not really. You're doing the cams because of what they have, their capabilities are, and you're doing the throttle bodies because of their capabilities. The two of them work together. I'm sure there is a cam tuner out there who will tell you exactly what you have to do to get an ITB specific camshaft. I have never run an ITB specific camshaft, and I have seen significant gains on the Miata engines I have just bolted these things onto. So, well, I'm sure there are some people who live in the world of camshafts who might be able to come up with the absolute perfect thing. It's not necessarily a requirement. Same thing with injectors. There's nothing special about injectors for ITBs as long as they are big enough for the power you're making. And you know, if you're running a huge turbo into a pressurized plenum and you're making 400 horsepower, you need enough fuel for 400 horsepower. If you're running it on one of my engines, which are 175, 180 by the time I was done with that 2 liter, you need enough fuel for 180 horsepower. So something that would run even stock injectors will keep up with that. The fuel rail solutions are often a little strange on throttle bodies. This one, TWM did a really nice job on this kit. This is a nice piece of machined billet extrusion from the looks of it. And that just bolts on here, and the injectors sit in there. Depending on the design choices made by the designers, you may need different injectors, but that's the important thing to remember. We did have a question about the ideal injector location. I'm not enough of a fuel flow scientist to say if it's better to have it here or have it at the port. I couldn't tell you. So I know these ones, they were in here. That worked out pretty well. So that's all I can tell you. This is more likely the sort of fuel rail you're going to see. This is a modular unit. Well, actually, it goes this way around. That the way this particular one was built, and this is the one that was in the picture that we used to promote this video. It had an adapter, and then it had basically a twin throttle body setup, like a dual carburetor kind of deal, dual barrel carburetor, and then it had a second one over here, and each of them had their own little fuel rail, and these fuel rails stuck together with these cool little connectors and O-rings, and if those O-rings start to fail, you get nice fountains. Again, Xander discovered that servicing one of my old engines after it had been sitting for a decade or so, but that is a more usual way to see the fuel rail handled. I'm not going to push that on there because those are dry O-rings. So anyhow, I'm going to show you a neat thing about these runners before I get into some of the other questions. You'll notice that the shape of these, they have a very distinct shape, and they're not all the same. These two have a very different shape to the bell mouth. And bell mouth shapes, if we've talked about it in the past, I did a video called Failed Experiments a while back that talked about some brake intakes we were working on. This is a 3D printed model of one. But this is the ideal bell mouth shape we were working with. And so that is what we were looking for, ideally, in a throttle body horn, is we want to have that same bell mouth. In this particular case, I forget what the name of this particular one is, but it's a... I'm sorry, it's gone. But it has this very specific shape, and this is designed to accelerate the air as quickly as possible. And this will pull in more air than just an open pipe. We proved that in that video. And so it's interesting looking at these. I would think that this silver one should actually be more effective than the black one because it has closer to the ideal bell mouth shape. Now you can't get into trouble where it is also bigger, and you may not actually have room to put them in there. So that is a factor. As always, packaging rears its ugly head. But it's interesting to look at when you're looking at these things because I have 5 distinct intakes here, and they're all slightly different in terms of this one has almost no bell mouth at all. This one is more. This one is quite nice looking. This one is long, so it's got more of a tapered setup to it, but they're all a little bit different. Anyway, little aside on that one.
Someone wants to know if they're parabolic.
If they are parabolic, excuse me, folks, I've been talking a lot. It happens. God, I can't remember what the name of this particular shape was. I found it in a scientific paper or an engineering report, basically on someone who'd been doing a lot of testing on this, and I forget what the term of it is. It's not a straight parabola. It's a little more interesting than that. But there's a lot of interesting CFD out there. If you go out there looking for bell mouth intakes, you're going to find some really interesting stuff out there. Not necessarily on an enthusiast site, but in guys who are doing actual research for, well, airplanes. It shows up a lot, of course, because they're airplane intakes. But you'll also find them for engine intakes as well. And I'm sorry, I don't remember what the name of this one was. It's right on the tip of my tongue, but hey, well, that's what you get for watching live videos, isn't it? We can't edit in the real name later. Not eccentric. Okay, so some of the questions we have come up with. Oh, one other thing. The method of the actual throttling. These are butterfly valves. I mean, this is basically a small, tiny version of what's on your Miata from the factory. Simple. Fairly easy to work on. They do need to be synchronized, which answers one of the questions that was in here. They all need to open and close at the same time. So just like you used to with old school carburetors, multiple carburetors, you had to synchronize them. It's the same deal, and that's why these are all adjustable. So you can make sure they all open and close at the same time. And there's all sorts of old school ways to do that. Basically, you measure. There's a special little tool that measures the amount of vacuum each one's pulling. You put it in there and check it and make sure they're all running the same. But they need to be synchronized. But that is the more normal way. The picture that we used as a promotional picture for this video was actually roller barrel throttles, which is a really cool concept of basically it's a cylinder with holes drilled in it, and the cylinder rotates. And so when it's wide open, those holes are lined up with the bores of the throttles, and there's absolutely nothing in the way. It's a completely wide open setup. And then as the cylinder rotates, they pinch off, and that closes it off. Very cool setup. We borrowed ours from, I think it was a Titan unit. It was the same one that's often used on Caterhams. It was a little finicky. We had trouble getting it to seal properly around the edges. It had a big jump in airflow right when you first opened it up. So, the throttle response off idle was a little aggressive, but it was very cool. And in theory, it's absolutely fantastic because, there's absolutely no restriction whatsoever. And that engine performed very well. It was a strong engine, and it's currently living in a 1,300-pound Westfield, so it's in a very happy place. The other sort of throttles you see is a slide throttle. And you see these on motorcycles a lot, and that is basically, it's a plate with a hole in it, and it slides up and down. So, when it's in the full throttle position, the hole lines up with the hole there, nothing in the way, and then it slides back and closes on that. More common than rollers, probably easier to package than rollers, suffers a little bit of a problem with side load. If there's a lot of aerodynamic pressure on that plate, it can have a little bit of stiction, doesn't necessarily want to move. But it's a common motorcycle thing, so it is a solved problem. So it's kind of a neat way to do it too. And you'll see both of those out there. I don't know of any slide throttle commercially available options. And I don't think I've ever seen a roller barrel one on a Miata engine anywhere else other than that one we built because it was very expensive. But it was very cool. Oh, man. So some of the questions we've had. Will they fit with an FM shock tower brace? And the answer is maybe. Because, of course, it all depends on the geometry of the ones you had. These ones, they do. When I was running them on my car, I had an FM shock tower brace on the car, and they fit. So the answer is they can, but I'm not going to say they all do. And it also depends on what you're doing for that intake, plenum, and what's going on the outside of it, how long your runners are, packaging. There was an interesting question about variable intake charges. And basically what Mazda did on the 787 Le Mans car is they wanted this capability. They wanted short runners and they wanted long runners, so they made runners that could change length. So they actually slid in and out. And there's videos of these things on YouTube making a stupendous racket like only rotaries can, but they actually changed their runner length depending on what they're looking to do. You're not going to find that off the shelf. I want to see somebody build that. Please, somebody build it. There's guys building free valve setups for Miata engines, I'd like to see somebody build a variable length intake for individual throttle bodies, please. But yeah, that would be a very interesting thing to try to build. One of the questions we got is, where do you get things like vacuum for the brake system? You know, you have a brake booster. How do you get vacuum for that? And the answer for that is off these four little guys down here and that vacuum chamber that I discussed earlier. You can use that to feed the vacuum booster for the brakes. When I was running this setup on my track car, which spent a lot of time at full throttle because that's what track cars like to do, I never had problem running out of vacuum for the booster. Because of course there's a check valve in there. So as long as you're pulling some vacuum at some point, you'll have vacuum to use, at least a certain amount of vacuum to use for later. So you pull it off, again, these individual things. Simply going to an unboosted setup, that's kind of, I wouldn't sacrifice my chosen brake setup because of the difficulty of implementation. So it is possible to run boosted brakes with these things. You just have to have that little vacuum accumulator, basically, I suppose is what it is, that has the idle speed control valve on it as well. A little more work to do, a little messier in the engine bay, but definitely big improvement on drivability. Do you have a question there, Travis? Okay. The high altitude effects. What effects do they have at high altitude? They have in terms of engine output, they have the exact same effect as any other naturally aspirated car. In terms of, we have less air up here, we have 20% less air than you have down at sea level, so we make approximately 20% less horsepower because there's just less air to burn. And throttle bodies do not change that equation in any way. But you do have to make sure that they are properly set up to deal with the changes in ambient pressure in terms of what 75% throttle means. That has to be tuned correctly. So there is that effect on throttle bodies for altitude changes, but it's not quite a power. That's a tuning thing, making sure you have the right parts in place to be able to tune them properly. Do they work better on high compression? And that is, of course, what I mentioned earlier, is that the things you do to make power naturally aspirated are things: high compression, spin it fast. You want the cams to, be biased towards the top end so that you can spin it fast. And the throttle bodies are part of that recipe, but they don't necessarily interact. You don't need high compression to run throttle bodies. You don't need throttle bodies to run high compression, but they will both be happier working together because both of them are working towards the same goal, if that makes any sense. Do they need to balance? Yes. How to tune? And we got a lot of questions on how do I tune this? What ECU should I use? And that is not my area of expertise. They tune like any other naturally aspirated engine, honestly, other than the fact that they run in a much narrower vacuum range. Having that vacuum accumulator helps quite a bit. You're definitely going to want to have an ECU that is capable of dealing with that blended TPS and map signal. I have made them work on a Link ECU, which did not have that capability. It ran purely off map, but it did have to be retuned for gross altitude changes. When I take that thing down to sea level, I had to basically, because of that problem where it only used 2 of the rows, those rows changed depending on which one. At sea level, it had more pressure available. So I had to retune it. I just had to move some stuff around. Obviously not the best way to do it, but it is possible if you are dealing with a regularly consistent altitude range. You can get away with that, but it's not the best way to do it. As for what ECU, I cannot really recommend one specific one. The guys in the UK, they're undoubtedly using ME221s. In the US, I suspect that most throttle body setups are being run on megasquirts, and that's simply a reflection of the favorite ECUs for those two markets. That's just how it works. The ME221 has much better support in the UK than it does in the US. It is a much more popular ECU over there, so you see more of it than you do in the US, whereas the US, home of the megasquirt, we tend to see a lot of megasquirt stuff. Any questions there, Travis? Because I'm running out of stuff in my notes. I know you sent me a lot of questions, but most of them I think I've covered. Okay, well then I'm going to say that me yattering on for this long has been long enough. If you have any questions, please do put them in the comments. We will get to them in another comment as soon as we can. Thanks for your attention. Thanks for all the questions. These talks are fun to do, and they're more fun when people send in questions and comments ahead of time because it gives me something to talk about. It makes me feel like I'm not just standing here and talking at poor Travis. I know we don't sell any of these parts, but it's interesting stuff to look at and play with, and what the heck. We'll be back with something next week that's probably a little less esoteric than individual throttle bodies, something perhaps a little more related to what we do day to day at Flyin Miata. But for the time being, thanks for your... Do we have a question there, Travis? Someone's getting in under the wire.
One quick question.
One quick question.
Could and would you daily drive a car with individual throttle bodies?
Could and would I daily drive a car with individual throttle bodies? I have. Now, my definition of daily driving, I have a lot of vehicles, so there's no one car I drive every day for 3 hours in Atlanta traffic kind of deal, daily driving. But yes, I have regularly driven cars with individual throttle bodies to work. The biggest downside is the noise, honestly. This was on a very high compression engine. It was a very high performance car. But the sheer amount of hammering that came out from underneath the hood, and again, you think it's cool, but you spend half an hour locked in there with that thing driving at 40 miles an hour, it becomes less cool. It's a lot more fun on a Sunday afternoon on an open road or screaming up towards the corkscrew at Laguna Seca. The noise is much cooler there. But yeah, that's the biggest problem. If you have it set up well with an idle speed control valve on a separate little vacuum canister, if you have it tuned well so it starts when it's cold, these are the hard things to set up in tuning. You know, full throttle tuning, that's easy, but getting it to start when it's right around freezing outside without having to hold the throttle open, that sort of thing, if you can get it tuned properly to that, I don't see a reason why you couldn't. I mean, this thing is a great daily driver, and that's got 8 throttle bodies. You're only talking about 4 from Miata. But you have to look at how it's implemented. It's got those 2 maps, it's monitoring, it's metering all the air that goes in the engine. It has the long runners for lots of torque. You know, they have made this a daily drivable ITB setup, but it was a lot more complicated than simply buying this thing and sticking on the side of the intake manifold, or in place of the intake manifold. So yes, I would daily drive an ITB car. I would happily daily drive that thing. But you just have to be aware, if you're going to run them in the more raw format, that's going to affect the experience. Any more questions there, Travis? That was it. We have answered all of the questions on the internet about ITBs, which is, I think, a pretty good way to finish off this video. Thanks for your attention, folks. We'll be back again next week with something else. Again, if you have questions, throw them in. Oh, Travis's hand moving? Nope, okay. Trying to read his body language here. I'm going to sign it off with that. My name's Keith Tanner. Thanks for paying attention. Hope to talk to you soon.